general that is with teenagers and report gas absorption. To start with, here is Miss Kabuhat for the objectives. Hope you learn and enjoy. At the end of this discussion, it is expected for us to understand the basic principles behind gas absorption, to illustrate the importance of gas absorption and its industrial application, and apply material balance and mass transfer formulas for the solving of problems regarding gas absorption and theoretical cases needed for the design of gas absorption hours. For the general principle in gas absorption, here is Mr. Law. Bonjour classmates and non-attendants. So I will be first discussing about absorption in general. So it is the incorporation of a substance in one state into another of a different state. It is observed when liquids are absorbed by a solid or when gases are being absorbed by a liquid. An example to illustrate this is when crisp fingertips turn salty after absorption of moisture from the air. On the other hand, absorption is a physical adherence or bonding of ions and molecules onto the surface of another thing. This is observed when reagents are absorbed to solid surfaces of catalysts. An example to illustrate this is when solid carbon pellets absorb the red dye when dissolved in water. So we will play a short video clip illustrating the difference between absorption and absorption. So here.
Absorption and adsorption. Some tea accidentally falls while you're studying. What is the best way to remove it off immediately? Click on the right option. Yes. Now watch the tissue paper suck away the spilled liquid quickly. If we had used ordinary paper, the tea would not be completely absorbed. Tissue paper absorbs a liquid and ordinary paper adsorbs a liquid. How are these two different? Let us learn more on them. Let's understand absorption and adsorption a little better. Absorption is the passage of one substance into or through the bulk of another medium. The absorbed substance spreads to saturate the whole of the medium to form a solution. The mixing with the other medium's environment is so well that one fails to recognize its existence as a separate entity. In contrast, what happens during adsorption? Adsorption is the addition or sticking together of molecules of a gas, liquid, or dissolved solids to the surface of a solid or sometimes a liquid. The molecules are loosely held by the surface and can easily drop off.
Alright, so that video clip basically shows or illustrated the difference between absorption and adsorption. So now let's move on to our major topic, which is gas absorption. This all scrubbing. It is an operation wherein a liquid and a gas come to contact with each other with the purpose of dissolving one or more components of the gas mixture and to transfer these components in the liquid state. So there are three general principles governing gas absorption. So the first is diffusion of the solute gas molecules through the host gas to the liquid boundary layer based on a concentration gradient. The second one is the solvation of the solute gas in the host liquid based on gas-liquid solubility. The third and final one is the diffusion of the solute gas based on the concentration gradient and thereby depleting the liquid boundary layer and permitting further solvation. So, to discuss further about the theory and the basic principles, let's welcome Ms. Orla Spanch. So, hola classmates. So, first, let's talk about gas absorption as a unit operation. But before that, what is a unit operation? Mr. Zamora, you look so handsome today. So, what is a unit operation?
The unit operation is Process kung saan walang chemical change.
Oh, correct. So, and it differs from unit process by Ms. Ilagan to unit of today. So, what is the unit process?
Well, in contrary to Mora said, I think it involves chemical reaction.
Thank you, classmates. So, gas absorption is a unit operation in which a soluble component of the gas is transferred into a relatively non-volatile liquid absorbent. So, to visualize this clearly, it is the mass transfer of the gas component from the gas phase into the liquid phase. So, it is said that the gas component is absorbed by the liquid. So, the liquid used in the gas absorption process is referred to as the absorbent, and the component absorbed is called the absorbate. In the simplest case of absorption, none of the liquid absorbent vaporizes, and the gas contains only one soluble constituent. In more complex cases of absorption, several components may be absorbed, and part of the absorbent may vaporize. So, let's welcome Ms. Lovely Kabuhat.
I am here to discuss gas-liquid equilibrium. So, we will use the SO2 air-water system to illustrate the experimental data in the gas-liquid equilibrium. So, an amount of SO2, air and water are put in a closed container and shaken repeatedly at a given temperature until equilibrium is reached. Can you imagine it? Samples of the gas and liquid are analyzed to give a partial pressure PA in atmosphere of SO2 in the vapor in equilibrium with the mole fraction XA of SO2 in the liquid at 293 Kelvin. So this is the obtained data in the experiment, and in Triantropoulos Appendix A 3-19 we can see a plot of partial pressure versus mole fraction. As we can see, there is a straight line there that follows the Henry's law. Let us take note that Henry's law is applied to low concentration conditions. Henry's law is PA equals XA, where H is the Henry's law constant, PA is the partial pressure of SO2 in the gas, and XA is the mole fraction in the liquid. If we divide this equation by the total pressure P, we will obtain YA equals H prime XA, where H prime is the Henry's law constant, and this is equal to H over P, and YA is the mole fraction in the gas, and XA is the mole fraction in the liquid. Let us take note that H in the previous equation is independent of the total pressure, while the H prime is dependent to the total pressure. The previous experiment is on the SO2 air-water system, but we can also obtain the Henry's law constant for other gases at various temperatures using table A3-18, also from Triantropoulos. So, to discuss principles of interface mass transfer, here is again its Banos.
So, I'm back. So, let's discuss about the field concept in Banos first. As I've said before, absorption deals with the mass transfer of the gas component from the gas phase to the liquid phase. So, let's see this typical gas-liquid interface. In this, the gas molecule will diffuse from the body of the gas phase into the gas-liquid interface. Then crosses that interface, that will go to the interface of the liquid phase. Then diffuses, finally diffuses to the liquid phase. So applying the simplest and most elementary method, which is the field theory, we can say that the resistance to diffusion is equivalent to the stagnant film of a certain thickness. So, here is a typical gas liquid interface in which there's three flow regimes. So first, the laminar fill. Second one is the transition zone with some turbulence, and the third one is fully developed turbulence. This interface can happen in any part of the gas absorption equipment where there is gas contacting with the liquid phase. So this is so hard to analyze, and so therefore we will use the two field of management.